is now starting. So over to Stephan to talk to us about user experience in air traffic control. You have the floor.
Thank you very much. So I'm currently a postdoc at the University of Würzburg, chair for psychological ergonomics. And this is from a project that ended almost 3 years ago. So my memory is not entirely fresh, but I'll try to meet the expectations of your very professional questions. To those who are, as I heard now, rather from a human factors background, we did not do that. We took a more playful user experience approach to air traffic control. This was a collaborative project with the DFS, which is the German air traffic service provider. And so most of you will already know, as I took it, that, wait, now PowerPoint is working, that this famous fellow on the internet is not an air traffic controller, but a runway worker. The air traffic control is entirely different and way less visual to the traveling passenger. So air traffic controllers are in charge of communication and direct air traffic. So they make sure that from the start of an aircraft to its landing, everything follows a safe, structured, and efficient pipeline. And in this project, we focused in particular on the approach position, or more specific, the feeder position. So the approach would pick up incoming traffic from the en route controllers and then forward it to the approach feeder. And the feeder position would make sure to kind of condense traffic in a still safe but as close spacing as possible to make the most use out of the runway, and then hand over the traffic with the reduced spacing to the tower. All arrows that you can see in this visualization are communication indicators. So for instance, the communication with pilots is mostly via radio, but among other colleagues on the air traffic control level or also with supervisors, communication is often via phone or squawk box. So again, our highlight was the approach position in the feeder here. As some of you may know, air traffic control is one of the classical research fields in HCI and also human factors. And since the 1940s, controllers documented the clearances which they then radioed to the pilots on paper flight strips. And this is still the fallback system in most countries of the world, or even still the primary documentation system. And somewhere in the 90s, when complexity of traffic increased over time, organizational and technical innovations were required. And so approaches were made in HCI to make a digital solution to this paper flight strip. However, Wendy Mackay, for instance, in her 25-year-old paper, demanded that the role of the paper flight strip and its social and also historical accounts need to be considered in the design of new systems. So this small flight strip here plays a really important role also internationally. And she predicted that the physical interaction between controllers and paper strips is not very easily to be replaced. However, eventually those paper flight strips were replaced either by electronic flight strips or by entirely stripless systems. And here in the picture, you can see a version of a paperless flight strip system. So people try to imitate the paper flight strip and put this on this digital display here, taking away the three-dimensional components, so you could not take the strips out of the system, but they were still there and you could rearrange them. So in this work, we first examined in an ethnographical approach how air traffic controllers used those systems. And they had a setup as indicated here, where display A is what I just showed you, the paperless strip system. Display where they document just anything, any clearances that they give. Display B is the main radar screen, where all the traffic movements in the air are displayed, and display C is a ground display. So they use mainly those three displays to retrieve information before they give any clearances. The displays on the left are further communication and information systems, and I won't go into detail what those can do. So the contributions in this project were gathering insights on user experience that is currently already prevalent in their working style, and those were qualitative studies. Then based on those qualitative studies, we redesigned the entire workstation, and finally we had a UX evaluation, a summative UX evaluation, where we compared our prototypes also with the currently deployed system. For the sake of brevity, in this seminar, I will not go too much into detail on the design process, but it is published, and you can, of course, also ask me questions about that later on. From the methodological perspective, we firstly conducted contextual inquiries following the contextual design process as suggested by Holzblatt and Bayer. Then we took all those qualitative notes and modeled them into experience models and affinity diagrams, conducted a wall walk, and then proceeded with those key insights and design ideas into a visioning process, from which we then generated iterative prototypes and finally did the evaluation study, which strictly taken is not even part of the contextual design process anymore, but rather extends it. So jumping into the insights, what we wouldn't even have had to do research for is to learn the priorities of air traffic control, because they propagate them everywhere. So the priorities in air traffic control are safety, structure, and efficiency, and in exactly that order. When we look at those priorities with a UX or HCI lens, then we can see that safety and efficiency is already considered. For instance, in the ISO standard 9241-11, efficiency is literally there, and safety is kind of there. It's hidden behind the reduced risk of harm. And also taking another lens, that of intuitive use, safety and efficiency are covered. So from an intuitive use perspective, if we achieve intuitive use, we require only a minimum of cognitive resources. And as a consequence of that, we have a lower error rate, thus increased safety, and are also more efficient due to the lower mental workload. What is entirely lacking, however, from those priorities at the moment, but would be part in various user experience definitions, are hedonic experiences. So we wondered whether pilots or also air traffic controllers don't have any hedonic experiences at all, which they claimed. However, this is not the case, and I'll just share a row of insights from this ethnographic work first. So our first insight from the qualitative data is that digital is today indeed faster and more stable than paper, thus contributing to efficiency, of course. With respect to the stability, Mackay observed the breakdown of strip printers as a common occurrence. Today, the paperless strip system runs so stable and breakdowns are so rare that centers schedule special training for the fallback system so that people don't unlearn how to use those paper strips. One controller even told us that with the paperless strip system, they were faster than they ever were with the paper strips. And the reason for this improvement is that they used to follow the guideline write while you speak. And in the today's pen-board interaction, they start to document as they speak, but the clicks are just so efficient that they finish documenting before they finish speaking. And so the verbal communication to the pilot outlasts the time it takes to document the clearance. And so this leads us to insight number 2. Today, radio is the new bottleneck. The most prevalent limitation on how much traffic a controller and approach can handle is the radio frequency. Only one actor at a time can speak on the frequency without causing disturbances. To reduce traffic on the radio frequency, controllers usually combine radio messages, up to 3 at a time. When pilots lack radio discipline and waste the valuable resource of time on frequency, controllers get really stressed. So the question here, the design implication is, why don't we replace the error-prone spoken language channel with preset recordings or written messages? And the reason for that is our third insight. The speech on radio carries extremely rich information. Controllers can retrieve valuable tacit information from the audio channel, for instance, how the emotional situation in the cockpit is. And they even can do that when the audio quality is impacted. So learning about the mood or the general atmosphere in the cockpit is important, but they can also use their own voice on the radio channel, for instance, to emphasize clearances, to make them more prevalent, standing out. The fourth insight we gained there is about controller situation awareness that extends beyond their own workplace. And so I highlighted the ground radar up there because the usual pipeline in the communication here would be that the tower controller sometimes require a gap in the incoming approaching traffic to squeeze in a departure. And if they need this gap, they call up the traffic controller on the approach position and ask them to make a gap. However, what we observed was that approach controllers rarely received those calls because they already assumed the needs of the tower control by using this ground radar. And so they saw when new aircraft were rather advanced on the taxiway or already in the starting position. So they just created a gap for the tower control, and this brought along 2 benefits. One for the tower controller, who did not have to make the request anymore and just got their needs fulfilled. And also the approach controller, who thus achieved less interruptions in their communication workflow. What we also observed and was really interesting, also considering the definition of efficiency, were different working styles and modes of operation. We called one of them standard advocates. So a standard advocate would say, I am most efficient when I save cognitive resources on the controller side. So they would follow the given standard, which is totally fine, and thus save on the communication, because if no communication happens, everyone follows the standard. The tinkerer, however, would do their job slightly different. They would say, I am satisfied with my work when aircraft in the final lineup appear like pearls on a necklace. So those are people who put in a little extra effort, who don't save on their cognitive resources, but who would define the efficiency as making the most efficient use of the runway. And so those are 2 entirely different perspectives. From a user experience point of view, we would say that only the standard advocate really follows efficiency, and the tinkerer is more maybe competence motivated, and well, what they do is not efficient for their own operational style. And when they put in the extra effort, they also really appreciate if this gets acknowledged. So for instance, the approach controller number 4 here said, when a pilot or tower controller thank me, my work brings joy. And another instance for good manners is, the pilot said sorry after the miscommunication. I highly value this. And as you can see here already, joy, values, that's not efficiency, that exceeds efficiency. Here we get into value-driven design or value-driven air traffic control. Another insight was the preference for one individualized workspace. You already saw that they operate on 7 different screens at the moment. In their left hand, they hold the push button, or in their non-dominant hand, they hold the push button for radio control. They have the pen in their right hand, and you see another 3 devices laying there, waiting for them to pick them up, but they have no spare hands for them anymore. So it would really be nice to have a more holistically designed workstation instead of this historically grown set and cluster of displays and interaction devices. Also, they can apply different settings, and they kind of gather preferences during their career. And one air traffic controller said that they needed 30 to 40 clicks just for setting up their workspace. And considering that their shift lasts about 1 hour, they have to do this multiple times a day. And when they switch shifts in between, the next one has to set up their display as well. So there's huge potential for preference design there. Finally, I praised technology in the beginning as it made people faster than they ever were with paper, but it did, of course, not remove all challenges. So, for instance, they have this variety of input devices now. Then there's also less non-verbal interaction between air traffic controllers. Previously, they had to kind of use this paper strip and just hand it to the next controller in the next sector. And now this handover where tacit information like, are those soft or swift movements? Is the person stressed in this interaction? Is not there anymore. Now they just click on the strip in their digital interface, and it gets sent to the next controller. But I also observed instances where it unfortunately got sent to the wrong controller, and a digital strip is way easier lost than this physical item here. So we used all those insights and many more and tried to create this one face to the ATC, one holistic interface vision. And in the vision that is most playful and that we are most keen on, we try to bring back the tangibility that paper strips once offered, but kind of was lost over the last 20 years in air traffic control domain design. On the last slides, I mainly reported on insights on psychological needs and values, but there is a list of requirements that have more direct implications for interface design in the paper. We iterated 3 prototypes twice before we did a summative evaluation, and I'll just shortly introduce the concepts behind those 3 prototypes that emerged from the visioning process. So first is the classical desktop interaction, using a mouse, using a keyboard, using one or not too many screens. So this is also implemented in many control centers worldwide already. Next, we tried a little more original approach and used what Microsoft back then labeled the novel desktop interaction. So using mainly touch screens, we omitted the pen that is still visible in this picture here, but we used the periphery device that is the Microsoft dial, which is it can be rotated and it can be pushed. I'll go more into detail later there. And finally, we took inspiration from the tangibility domain and created a more playful, tangible interaction. I believe it brings most insight into how those prototypes worked if I just show videos here, and I do hope they play. So credit for this one, for the flight dial, it was a student design project as to Simon Munschenk. And there are only two interactions with this flight dial. You can rotate it and you can push it to select aircraft or select values and then confirm them. So how does this work? We have a screen here that is also a touch screen with, in this simplistic case, only 3 aircraft that are on the final here already, or the last one is not. In the top line of the flight label, you can see the aircraft identifier, the call sign, and the other 2 lines are flight level, speed, heading, and another value that I just forgot. And the last row are the new items that are to be adjusted. So the difference to what is currently operational in most control centers in the world is that you can also document in the radar screen. Usually you would have 1 line less in this flight label and only see what is currently there, but you cannot assign anything new there. As you just saw, I'll just pause the video for a second. You could also create a vector there, so you could measure the exact distance between aircraft, but not all air traffic controllers that we observed use this feature. Most would appreciate another display, which is the history trail and anchors. So you can see the last dots where aircraft were 1 minute ago, for instance, or 15 seconds ago, and you have those anchors that, I'll just skip back again. Those anchors that, in this case, mean the minimum spacing that is safe. So the aircraft behind should not cross the red line here, but it would really nice if it flew on this green line, because the green line already considers the reduction of velocity until the landing. So this would be most efficient if it flew exactly on that green line. And in the first version of the prototype, we still had this legacy flight strip there, but we learned rather quickly that this is not necessary anymore. Air traffic controllers are not bound to this legacy interface, and they can operate the flight labels that we gave up there. So the mouse interface, the desktop interface, I will not show to you in detail, but it was a rather similar screen, just without the dial, but with a mouse interaction. And moving on to the next prototype. This was created by Johanna Gramlich and Selina Pauli. We started off with clay prototypes there and tested different forms. And finally, the forms that worked best, the tangible tokens that were most appreciated by air traffic controllers, that felt best between the fingers, we printed with a flexible filament in a 3D printer, so that we could also facilitate squeeze interactions there. And I do hope that sound is also passed on to Zoom, then you will hear
Center 61 Tango identified, descent 4000 feet, QNH 1013.
So this is live air traffic control radio frequency
Reduce speed 200 knots.
with the matching interactions for the documentation.
Zulu, turn right heading 170. Lufthansa 9 Zulu, turn right heading 240 and cleared ILS runway 26 right.
Okay, so those were the two prototypes. And in our summative UX evaluation, we compared them to the current workstation and tested whether the novel prototypes provided a better UX in a standard scenario than the controller's current system. This was a within design with 12 approach controllers, and they went through all 4 conditions. And after each condition completed the battery of questionnaires listed below. So this was the UEQ. In the short version, of course, they had to complete it 4 times. Then the hedonic and eudaimonic motives for activities, HEMA-R. And from Sheldon's psychological need inventory, we took the 2 dimensions, competency and autonomy. And there's a lot of results on that slide. So I'll start on the top right. The current workstation is always the gray bar, and the others are in the list by increasing originality, the mouse, the dial, and the tangible device. And as you can see in the top right, the overall user experience increased from the current workstation to all 3 prototypes. And the reason is mainly found in the hedonic dimension, as you can see in the top center. The values printed there are eta squared, eta partial squared. So those are rather large effects, even though not all effects were significant because we, well, had a rather small sample there. And on the pragmatic dimension, this is interesting because only the mouse achieved a significant different pragmatic effect there. However, going on to the hedonic scores on the bottom left, this kind of confirms what we measured with the UEQ. So the hedonic quality of all of our prototypes was higher than that of the current workstation. And interestingly, in the eudaimonic dimension, this is not the case. There was only one, well, the descriptively largest here between the current workstation and the dial had a partial eta squared score of 0.16, so still a large effect. And this is interesting because usually the eudaimonia dimension is associated with long-term importance, and all of our controllers had no long-term experience with our prototypes. So it's really interesting why the dial still scored higher in eudaimonia here. One of our assumptions is that it could have been because what really brought the eudaimonic effect here is the underlying task, and the dial contributed to them easily interacting with the data and facilitated that task. So maybe this is the reason. And not very surprising, on an interface that they had no experience with, the competence was not so high. So all here scored lower, and the tangibles, which were the most original, most unconventional interface, even significantly differed from the competence that they felt when they used their current workstation. The implications that we take from all this research is to not ignore the hedonic or eudaimonic dimensions of user experience in safety critical domains. So we found instances of hedonic values in qualitative data as well as in our summative quantitative studies. And we would encourage people to, on the one hand, deepen research in air traffic control, because we barely scratched the surface there. So this is only a first study, and we cannot even explain all the effects, what underlying factors exactly contributed to higher UX in one or the other prototype, for instance, and also to take this to other domains. For instance, Grundgeiger and colleagues assumed that the eudaimonic dimension would be higher than hedonism in safety critical domain of healthcare. However, just going back one slide, this is not even descriptively supported here. They are rather on par. So yeah, user experience may also vary between safety critical domains and has not been considered too much in the past, because most safety critical domains are rather expert domains that are more placed in human factors paradigm, and not too much user experience, despite we're getting there, has been done in the past. Also, for the designers among us, I encourage you to try playful designs, even though the domain may not explicitly ask for it in the beginning, because the more playful the design, the more insights you can derive from the research. There are a long list of limitations, and I'll only point out two here. So we use simple situations. This is positive testing. We did not want to overexert air traffic controllers without any training on the interface. Research indicates that some hours of training may improve the efficiency to an extent that they can use a novel interface as they did with their current workstation, but we did not have the time to do that. So we only gave them 2 to 3 minute introductions into each interface. We had an oversimplified context. There was no challenging weather conditions, no challenging traffic conditions, and only a few aircraft, mostly 3 or 4, on the radar. And also we only did this with approach controllers from one control center. And so other positions may have varying needs. Also, there is research that indicates that there are different styles between control centers. We found that there is different style between air traffic controllers, or even within air traffic controllers, because we also found people who tried to follow this tinkerer style as long as the traffic allowed, because this also is associated with way more communication. You have to give more directs to pilots. And so when the traffic load increased, people would jump back to being standard advocates. And finally, of course, time moves on. What we labeled the current workstation 3 years ago has been replaced in this control center. And the current workstation in operation there now is closer to what we introduced as the mouse condition. So it's a radar screen where the documentation is happening directly in the radar, and with a classical desktop interaction with mouse and keyboard. Interestingly, this desktop interaction is exactly what Wendy Mackay advised against in the 90s. So now we're there. Admittedly, desktops have changed a bit since 1999, but the interaction mostly remained the same. So this is our best option now. And looking at our data, also, well, it was the most pragmatic decision to make. And the hedonism is still improved. So the overall experience in this mouse condition has increased, at least according to our prototypically based data here. we haven't had the chance to do any new ethnographic research with this population. Finally, I want to come to the conclusion that, yes, we should add positive experience to the list in air traffic control, and maybe this is also an opportunity to try whether positive experience suits into the priorities list and other safety critical domains. I only scratched the surface there. We published a paper on the ethnographic work that I introduced in the first part. Then there's, of course, the Interacting with Computers paper here displayed on the right that is also carries the title of the seminar today. And there's also one paper in between. I didn't put it there. It's a pictorial in the TEI conference on how we designed the tangible interface there. And now I'm really looking forward to your questions. Thank you so much. You're still mute, Helen.
The typical Zoom age problem. Anyway, what I said was thank you very much. I learned a lot about air traffic control. So you pitched it very well for the amateurs in the audience. But I'll let some of the more expert people ask some questions first. So if you'd like to ask a question, please just raise your hand. I have someone who's raised their hand. That's Anke. Would you like to unmute yourself and ask a question?
Can you hear me?
Yep. Yes.
Okay. Thank you, Stephan, for the very interesting talk. So since we're working on related projects, I probably have a few questions. One that came up quickly in my mind was about the experience working with the air traffic controllers. So in our projects, sometimes they have been very reluctant to novel ideas because of their learning of procedures. So you kind of talked about I think it was the competency criteria, where they were stronger with the standard interface than with the novel ones. And so I wanted more like your insights on when you worked with them, like how open they were to your suggestions, or like how much they would like to remain using the existing interfaces, which they know very well.
Yeah, thank you very much. That is, in fact, interesting, particularly in that domain. I'm currently working on a project with anesthesiologists, and they are way more open to novel interfaces in their work surroundings. So yeah, for air traffic controllers, they were kind of reluctant in the beginning, not only to what we brought to them, but also to our methods. So particularly formative design iterations, where we posed questions like, how does this device feel in your hand? No one ever asked them that. So they kind of needed a bit to adapt to our methods, our questions. But once they kind of checked in and found the mood of our design workshops, they were really engaging in our playful interactions and kind of try to contribute there. And they also, I mean, the summative data speaks for themselves. They were not appalled by the playful interface.
Anke, if you've got other questions, go ahead. I've got Erin waiting, but
yes.
I think you can have a bit more time.
Okay. So one thing you talked about quite in the beginning was the observation that written text cannot completely replace the oral communication. So we are working on a project for deaf pilots, where the idea would be to replace the oral communication by written communication. So do you have any more insights on maybe how, if you use the UX aspects, is there any way you could make those written communications more usable or more interesting to the air traffic controllers and the pilots?
Yeah, that's interesting. May I ask you, are those pilots piloting commercial aircrafts
No,
or amateurs? Okay,
general aviation.
okay. So I had the opportunity to sit in the cockpit during commercial flights, and the pilots, when I suggested whether written communication would be a possibility for them, they said, no way. Particularly in approach, I have to look out of the window. I cannot look on a screen. Forget it. So sure, I mean, with text-to-speech and speech-to-text parsing, it's certainly possible to have in the near future kind of a translation there where air traffic controllers maybe send pre-written snippets of text that are then read out in the cockpit. So that would be an opportunity. I'm really curious how you tackle that with the deaf pilots, because they still have to look out of the window, right? Or maybe those are less busy airports.
Yeah. No, yeah, they do have to look out of the window. Yeah, we're currently still working on how this can be done, but yeah, could be combined with other modalities like tactile or something like this. But yeah, for sure, that's a challenge, of course.
Yeah. So our project focused on the approach control. We did not even design the pilot side in this project. Thank you.
Let me move on to Karine, and we can come back, and then I've got Josh, and then if you have another question, we can cycle back to you. We'll put you in a queue. I'm working out this big air traffic control metaphor to use here. Karine.
Yes. Well, first of all, thank you very much. It was very interesting and kind of resonated a lot with what we think, because I'm not an air traffic controller, obviously, so I talk to them sometimes. So my question is, did any of your prototype already include the onboarding by design? Because of course, when you change an interface in a safety critical environment, there is this big question, like, are we gonna do worse for a period of time, the time that they learn how to use the system, especially the tangible one, for instance, and that can create some criticality in there. So did you prototype now as if the transition period is ignored and something is going to happen as a transition, and then you have your prototype? Or are your prototype already including onboarding? So perhaps, for instance, it has to be an incremental change where you keep most of the interface the same, and just incrementally you change one tiny thing that adapts, and then one tiny thing that adapts, and then one tiny thing, and then you arrive to your fully fledged, final prototype? Or how did you envision these transitions?
Oh, that's a very good question. So actually, we did not do any onboarding concepts. So there is no good transition between this entirely new holistic design concept to an already existing cluster of screens. So we just ignored that aspect, but especially for the tangible prototypes, we thought this is certainly a way too playful interaction mode for peak traffic. So this was rather a concept that would perform best, for instance, during the night shift, as it is kind of engaging and playful and may increase the vigilance of controllers.
But I think so, for instance, what is interesting about the tangible aspect is, because I worked in an industrial design department and we looked at those tangible things. Sometimes we also look at like side interactions, or and for instance, the air traffic controller, to my knowledge, do not use their feet today. They could also just press a pedal to activate the radio, and it would not have to be one of their hands. Or, like there is other parts of the side interaction that could also be ambient in the room or whatever. But what I was thinking about for my first question, I was thinking, when we look at their acceptance of a situation, if we present the concept with already showing the onboarding, it could also lower the barriers of them projecting themselves, because I think sometimes in a disruptive change, because you don't see, you're a bit afraid perhaps that it's going to move from day one to the other, and you're going to have to relearn everything you've learned.
That's true. So to the food first. So the control center where we did our observations, they had introduced the food pedal to replace the manual push to talk button, but air traffic controllers did not adopt it well. So they just went back to blocking one hand the entire time. They did not like the foot pedal interaction there. Maybe it's too much effort, I don't know. The pedals were in some workstations still there, but no one used them. And to your other question, I believe that it would be a good transition to start using the interface in sectors with less traffic, so that people could kind of learn how they are operated and have a bit more buffer before they use them in sectors where there is peak traffic, or at hours where there is peak traffic, because traffic is not all the time the same, and well, at least not at the sectors that we observed. So they told us that it's the way they learned the new interface as well, and the one before that they just used it in less traffic and kind of gained proficiency in using it over time.
That's interesting. I have a last one, a short one.
Yes.
It's about, so in the scales you've been using, you have the psychological needs by Sheldon, and you only showed on the graph the competence and autonomy. Did you also use the other items by relatedness and no? So just those two?
We just used those two, so we tried to cook it down, because they had to complete the entire questionnaire battery 4 times. And so we tried to keep it as short as possible. And we were most interested in those 2 scales because we assumed that we could measure something there.
Because I think, but that comes from personal experience there, the voice modality, when you say there are a lot of implicit messages, that is entirely true. But there is another thing that has been striking me when I was a student pilot and I started learning how to contact them. And my instructor said, you have to say thank you. You have to contact them back and say thank you. Have a good day. And I was like, why? This is not efficient. I'm taking the bandwidth. Why would I say thank you? They've done their job. I've talked to my, coded message stuff. And they say it's important. It's like they are human beings. And I think part of the voice is, if you remove it, they are more machine-like. And now they have a very network type of job that is extremely human by nature.
Yeah.
And that you may have looked at in the relatedness scale specifically, or belonging to that community of pilot and aviation and stuff. But I was just asking if you had been measuring that time.
That's a really good idea, and we should have totally done that if we had also included the verbal communication in our studies. However, we only did the documentation part there, and there was no other end that simulated or acted on the pilot side. So if this was included in a future study, then yes, we should definitely measure the relatedness there. That's a good idea. Thank you.
Josh, over to you.
Yeah, no, very appreciate the talk and the discussion, because I'm super interested in this. So first off, the foot switch kind of surprised me, just because as a pilot we have a foot switch as well, and that's the one I use all the time, because I don't know, anytime I can free up a hand over a foot, I'm going to do it. But so I just thought it was intriguing. But as Kern was talking about the human side of things, what I was interested in is that most aviation mishaps, if not 99%, are human errors is actually the cause, whether it's ATC or within the cockpit talking pilot to pilot, things like that. And so, I got excited when you started talking about like a digital means of sending a message and displaying it in the cockpit, because, very often what we do in our cockpits in the Army is that the pilot on the controls doesn't handle the radios. The pilot not on the controls handles the radios. And so you're looking outside, you're flying the aircraft, you don't want to be bogged down by the radios, but you're listening to what the other pilot is saying. ATC may say, hey, turn to heading 240, and he repeats back, Roger, 270, and you're like, whoa. I think you misheard, but the things get messed up in the conversation all the time between ATC and us, and what you actually hear. And then you throw into there that the radios actually, depending on your distance to the source and things like that, the communication can get really bad. And so a digital message usually come through just fine. So our cockpit is a digital cockpit. We can send text messages back and forth to other aircraft, we can send text messages to ground units. So the idea of being able to get ATC instructions through there as well is awesome, especially because you have a history in your text messages where it's like, oh, what was our last clearance? Do you remember? Oh, yeah, okay, and be able to pull that up versus relying on your co-pilots just taking handwritten notes of what he hears over the radio. So all that stuff definitely got me super excited. But I was just wondering if it came up at all in your discussions with ATC about pilots that maybe, you know, English is supposed to be the universal language, but not everyone has the same English proficiency on the radios. So just wondering if it came up at all, like just miscommunication, how they handle miscommunication.
Yeah. Well, of course, I mean, you're probably familiar with data link communications, so it is already a thing in upper airspace. However, when I talk to approach controllers or also to pilots in approach, they claimed that the latency would just be too long. With spoken language, they get immediate feedback on the radio because the readback is kind of imminent. However, if they send a text message, how long should they wait until they know that the pilot saw it and until they get something back? Because 2 minutes is too long in approach. So is it 10 seconds? How long is it? And what if they don't respond? Is this kind of an interruption? Do they have to put them on hold then? Because it's not feasible anymore to squeeze them into the final. So this was the biggest discussion there, but I just took a note for myself to send you a paper because ignoring the fact of latency, we of course did research on text messages, and I'm happy to send it over to you later on.
No, I appreciate that. Yeah, and it's interesting because in our aircraft, we actually have a button that just says ACK for acknowledge. And so as soon as the message comes in, pops up, you push ACK and they get an immediate message back saying that it's been read and received. So, and it doesn't require a readback because the numbers they typed in are the numbers that are on the screen. So it's interesting that an ACK, I think, is faster than doing a readback.
Yeah, that's cool. Those are not commercial aircrafts, right?
No, continue. I thought you'd finished.
No, go ahead.
Yep, I was just asking, does anyone else have any questions? I have one little question, a very naive question. When you were talking about whether the air traffic controllers had hedonic experiences and user experience, they're doing something highly skilled and they're highly competent. And that reminds me very much of the concept of flow. So have people looked at optimal experience and flow in air traffic control, which could be very positive. It gives you a great sense of achievement, but also it might in air traffic control have a slight problematic aspect because when you're in optimal flow, you lose sense of time. And that's not good if you're an air traffic controller, I imagine. So I just wondered whether people have used that concept in air traffic control studies.
I must admit that I'm currently not exactly aware of any research there. There must be some. However, from personal experience, I can say that it's not too simple to measure flow, particularly in air traffic control.
Yep.
Because you cannot really measure it from the outside.
Yeah.
And
yes, you have to, people have, I mean, it would be interesting, and perhaps people have done this, to ask air traffic controllers and pilots, do they go into a state of flow?
Yeah.
Because one of the things I know, I really enjoy driving. I come from a family where we have many professional race drivers, although I have never been interested in being one, but I go and I've done advanced driving courses and I go into a state of flow sometimes when I'm driving. And that actually scares me a little bit because I know I'm becoming less aware of certain things. but I assume it's okay because I'm really, really concentrating on what I'm doing. But knowing something about the research on flow, it seems a little bit weird.
Yeah, that's true.
Just a thought.
It's a good thought. I don't know whether the task that air traffic controllers pursue, particularly with this long list of interruptions in communication from different actors, whether that wouldn't impede flow.
Yes, that might be the case. Because when you're driving, I think you go into flow when you're not having, when you're on a motorway or a long road and there are no interruptions.
Yeah.
And you're just driving perfectly. Anyway, just a thought to put in your mind to think about, because I think we're just at 2 o'clock, people are having to go, but people are writing messages in the chat saying, thank you, great talk. It was a great talk. I really enjoyed it. And we look forward to more research from you and more papers on this. And final thought for people who are there, we are going to continue the theme of flying because next month I and one of my colleagues, we're going to talk about using drones to help older people as an assistive technology, which is also a kind of weird and playful idea that has been more successful than we thought. So we will continue to fly next month. So thanks everyone for joining. Thanks very much, Stephan, for the presentation. I'll put it up on the website and YouTube in a couple of days' time. So if you've got colleagues who weren't able to come, they can look at the presentation video.
Thank you very much.
Okay.
Thank
Have
you
a
so
good
much.
afternoon, everyone. Great. Thanks a lot. I'll close down now. Bye.